Namaste. Welcome to the lecture series on the subject Basic Thermodynamics. This is Module 4, Part 2, Pure Substances, Lecture number 6. Myself, Dr. Satheesh Kumar, Associate Professor of Mechanical Engineering, Canara Engineering College, Bantual. So I will continue with the numerical on use of steam property tables. So let us solve this problem. Steam initially at 0.3 megapascal and 250 degrees Celsius is cooled at constant volume. Find at what temperature will the steam become saturated vapor. What is the quality at 80 degrees Celsius. What is the heat transferred per kg of steam in cooling from 250 degrees Celsius to 80 degrees Celsius. So initial condition of steam is 0.3 megapascal. So that is 3 bar and 250 degrees Celsius. So you have to find out whether the steam is superheated, dry or wet by knowing its saturation temperature at 0.3 megapascal. Then at what temperature will the steam become saturated vapor? So you have to know initial condition, then you have to find out. So usually from my just the knowledge what I have, so 3 bar and 250 degrees directly I can say that it is superheated. Even if you can check that is superheated, so it has to be cooled to become saturated vapor. So at what temperature it becomes saturated, I have to check. And also what is the quality of steam at 80 degrees Celsius, and what is the heat transferred per kg of steam in cooling from 250 to 80 degree Celsius. So at 300 kilopascal, that is what I told, 0.3 megapascal is 300 kilopascal or 3 bar, and 250 degrees Celsius, I can find that it is superheated condition. So how to find out superheated condition? So all of you open the table A1, go through 3 bar. Okay, so check out what is the saturation temperature at 3 bar. So definitely that saturation temperature is below 250 degrees Celsius, means the actual temperature is more than saturation temperature, so the steam is superheated. So once you find out that steam is superheated steam, so directly go to superheated steam table A3. So in A3 table, so there is a combination of 300 kilopascal, 3 bar and 250 degrees Celsius. Directly it is available. So I'm not showing the sample here. Directly you can open the book and you can check. So specific volume you can find it as 0.79644 meter cube per kg, enthalpy as 2967.9 kilojoules per kg. To find out internal energy U1, so substitute for H1 minus PV1, so you'll get as 2728.97 kilojoules per kg. So internal energy, as I told you earlier, it is not there in the table what we are using, right? So you have to calculate using the formula U is equal to H minus PV. Okay. Now the steam is cooled at constant volume. Therefore, so when the steam becomes saturation, so volume becomes Vg. So that is 0.79644 meter cube per kg. So from the table A1, so you have to search for the value 0.79644 meter cube per kg, but there is no exact value of 0.79644 meter cube per kg. So from the table you can find that you have the value of 0.88540 and 0.71840. So at 0.88540, so what you have to do is you have to search in the Vg column of the table A1, right? Vg column. So you cannot find 0.79644. What you can find is 0.71840 and 0.8850, because 0.79644 becomes in between, or comes not in between these two values. So corresponding to 0.88540, you can find out temperature as 120.33 and pressure as 2 bar, whereas 0.71840 temperature is 127.43 and pressure is 2.54. So the pressure what I want at 0.79644 is X and temperature to be taken as Y. Now interpolate. So X you will get it as 2.26 bar or 226 kilopascal, and Y is equal to saturation temperature, you get it as 124.02. You can see here the X value is between 2 and 2.5, so you get it as 2.26 bar, whereas Y is between 120 and 127, you get it as 124.02 degree Celsius. Therefore steam becomes saturated vapor at 124.02 degrees Celsius. So this is how you would find out the temperature or pressure at which the steam becomes superheated when it is cooled from 3 megapascal, that is 3 bar and 250 degrees Celsius. You see, 2 bar and 350 degrees Celsius you are cooling. So at 2.26 bar and 124.02 degrees Celsius, so it becomes saturated vapor. Very good. Okay. Now from table A2, now go to 80 degrees Celsius. Further you have to cool. Okay, now saturated, it should become wet, so you have to cool at till 80 degrees Celsius. So open the table, A2 table, 80 degrees Celsius, pressure is 0.4736 bar. You see, pressure has reduced drastically. VF is out note down, meter cube per kg, VG is out note down, meter cube per kg, HF kilojoules per kg, HFG also kilojoules per kg. So I didn't write the unit, but unit is available in the table, right? So everything is specific quantity, meter cube per kg, specific volume, enthalpy is kilojoules per kg. Okay, now V is equal to Vf plus X Vfg at 80 degrees Celsius. So your substitute for this constant volume process, V is 0.796 for given now also. Vf is given in this table for 80 degrees Celsius. Vfg is also known. So find out the dryness fraction at 80 degrees Celsius. So the quality of steam is 23.3% or 0.233 at 80 degrees Celsius. It is wet steam. Only 23.3% is the vapor and remaining is the liquid. So internal energy of this wet steam is nothing but HF minus U. You have to find out. For that, first you have to find out UF, then UFG, then you have to find out UF plus X UFG. Okay. So your UF is nothing but HF minus P into VF. You see, UF is equal to HF minus P into VF. If you substitute, so you will get UF as 334.85 kilojoules per kg and UFG as HFG minus P VFG. Same condition, 80 degrees Celsius. Okay, all these values you have to note down at 80 degrees Celsius. You will get it as 2146.59 kilojoules per kg, and U2, as I told you earlier, is nothing but U2 plus U2 is equal to EF plus X EFG. So if you substitute, you get as 835 kilojoules per kg. So this is how you have to calculate the final internal energy of the steam. Okay, so little bit of understanding of the subject is very much necessary to solve problems on steam table, use of steam tables. Okay. So heat transfer is nothing but change in internal energy as the process constant volume, that is nothing but U1 minus U2, because it's cooling. So that is why it is U1 minus U2, because initial internal energy will be more, final internal energy will be less, because it is cooling means heat is removed. So heat is removed means internal energy decreases. So it decreases to decreases by an amount of 1893.98 kilojoules per kg, which is nothing but the heat removed or heat transfer. Heat transfer in the sense it is heat removed from the steam. If you do U2 minus U1, you will get it as minus quantity. So negative sign indicates that heat is removed. That's also you can do. U1 minus U2 also you can do, or you can do it as U2 minus U1 also. U2 minus U1 means that is a better option as always there, because you get the answer as negative. So clearly indicating that the heat is removed during the constant volume cooling process. Okay. Now let us solve this problem. State whether the following samples of steam are wet, dry or superheated. Justify your answer. This is one of the common types of problems which appear in VTU question papers. You will be given certain conditions and you have to find out whether the steam is wet, dry or superheated. So 5 conditions are given, so I won't read this. So directly I will take up one by one these conditions, and then I will try to find out the condition of the steam. So let us take the first one. Pressure is 1 megapascal, absolute enthalpy is 2880 kilojoules per kg. So when pressure is given, so open the steam table at 1 megapascal or 10 bar. So note down Hg value. So Hg value obtained from the table is 2776.2 kilojoules. Means if the steam is dry, so you should have enthalpy of 2776.2 kilojoules per kg, and the actual enthalpy of the steam at given pressure is 2880 kilojoules per kg. That means your H value is greater than Hg. You see, the given H is greater than Hg, so that means it has already crossed the saturated point or saturated vapor state, so it has gone to the superheated state. See, this is, you have to compare it with Hg. If Hg, if it is equal to Hg, it is dry saturated. If it is less than Hg, then it is a wet steam. Now go to the second condition. Pressure is 500 kilopascal or 5 bar. Absolute volume is 0.35 meter cube per kg. So volume is given here, pressure and volume. So at 500 kilopascal or 5 bar, so note down the Vg, because we have to compare with Vg first. always. V given means Vg, H is given means Hg. So Vg is 0.37466 meter cube per kg, but given V is 0.35 meter cube, which is less than Vg. That means the volume is not yet reached the saturation point. So volume is still less. That means it is a wet stream. You see, stream is wet. Okay. Now go to this question number 3. Sub question number 3. Temperature is 200. Pressure is 1.2 megapascal. So let us note down at 200 degrees Celsius what is the saturation pressure. So saturation pressure is 15.549 bar or 1.5549 megapascal. So at 200 degrees Celsius, the saturation pressure is 15.549 or 1.5549, but given pressure is less than that. Given pressure is less than that. So if pressure is less, then the steam is superheated. You see, for only for pressure, right? Temperature and other things should be greater than the value at the saturated point. But pressure, if it is less than the saturation value, so then steam is separated. This is because you see, now all of you open table A1 and find out the temperature at 1.2 megapascal or 12 bar. So if you find out the temperature saturation temperature at 1.2 megapascal will be less than 200 degrees Celsius. So saturation temperature is less, but 200, the actual temperature at 1.2 megapascal is high. So the steam is superheated. This is another way to check whether the condition of the steam is superheated or wet or dry when pressure and temperatures are given. Either you can compare using temperature tables or you can compare with the pressure tables. If you are comparing the pressure table, so the saturation temperature at 1.5 megapascal should be less, actual temperature should be more for steam to be called as superheated. Whereas pressure at, if you are looking at the temperature table, the saturation pressure should be more, actual pressure should be less when the steam is superheated. I hope it is very much clear. Okay. Now let us go to the next condition. Temperature is 100 degrees Celsius, entropy is 6.88. So once again you have to compare with Sg. So Sg at 100 degrees Celsius is 7.3554 kilojoules per kg per Kelvin. So given value of S is 6.88 kilojoules per kg per Kelvin. So S is less than Sg. So therefore steam is wet. See, for all other property values like enthalpy, entropy, specific volume, internal energy, if the given value is less than the saturation value, steam is wet. If the given value is equal to saturated value, the condition is saturated steam, and given value is more than saturated steam, then it is superheated. So just remember that. Okay. Now coming to the last part. So pressure is 10 kilopascal, that is 0.1 bar, and enthalpy is 2584 kilojoules per kg. So here at 10 kilopascal or 0.1 bar, Hg is 2584.8. So H is equal to Hg is exactly, it is equal, neglect 0.8. So you can say that steam is dry saturated. Okay. Okay, now let us solve one more problem and then we'll wind up this lecture Okay. So a vessel of volume 0.04 meter cube contains a mixture of saturated water and saturated steam at a temperature of 250 degrees Celsius. The mass of liquid present is 9 kg. Find the pressure, the mass, the specific volume, the enthalpy, the entropy, and the internal energy. Interesting problem. Volume of the vessel is 0.04 meter cube. So mixture of saturated and unsaturated steam, that is wet steam at a temperature of 250 degrees Celsius. Mass of liquid is 9 kg. So here V is total volume is 0.04 meter cube. Since it is a saturated wet steam, saturated condition, Ts is 250 degrees Celsius, MF is 9 kg. Now from data and book at Ts is equal to 250 degrees Celsius. So note down Psat. So that is one of the answer actually. The find the pressure. Okay, so that is 39.776 bar. HF you note down. Okay, HFG you note down. Then VF, VG, SF, SFG. So all these values you have to note down because you have to calculate specific volume, enthalpy, entropy, and internal energy. So all data is required. So total volume is given, so that is nothing but V is equal to MF into VF plus mg into Vg. So here capital V is given 0.04, MF is 9 kg, VF you have to note down from the table, mg is unknown, vg is from the table, so mg you will get as 0.5743 kg. Okay, I didn't substitute there, I directly wrote the answer, but you take a calculator and verify this answer. Okay. Now total mass is nothing but m is equal to mf plus mg, so 9 plus 0.5743, so 9.5743 kg. Dryness fraction x is equal to mg, because this is very important, because once it is wet steam, so without knowing the dryness fraction you cannot find out the other property values. So x is nothing but mg divided by mf plus mg, so it is 0.05998, and now we have to find out the all other quantities. Before that, let us start writing answers. So pressure is 39.776 bar, that is what you noted from the steam table at 250 degrees Celsius. Total mass just now we calculated. Now specific volume V is equal to capital V by M. So M is 9.5743, you get as 0.004 meter cube per kg. And enthalpy H is equal to HF plus X into HFG. So all of the formulas for wet steam are used to find out the other properties like enthalpy, entropy, and this entropy, entropy, and the internal energy. Okay, so enthalpy is nothing but H is equal to HF plus XHFG. If you substitute, you get as 1188.75 kilojoules per kg. Then entropy, S is equal to SF plus X into SFG, that is 2.9901 kilojoules per kg. So all of you can cross verify these answers. Don't simply copy. Okay, and internal energy is equal to H minus PV. So 1029.646 kilojoules per kg. So I request all of you to work out these problems. Don't simply listen to the lecturing. You can pause this video at any moment of time for individual formulas, substitute and calculate. Try to understand the subject properly, so that you will be able to solve any problem given from this chapter. So with this I conclude this lecture number 6, and also I conclude the numericals on use of property tables, steam tables. Okay, and I thank all the viewers for watching this video lecture series, right? So I almost covered all lectures, only irreversibility is left, so I try to even come up with the video lecturing for that also. Okay, so thank you all the viewers. If you really like this video lecture series, kindly press or click the like uh, button in the YouTube channel. Thank you.